Hi, this is Shruti Salian, and this tutorial helps you make your own MapReduce application using Java and run it on Cloudera virtual machine. You can also use Hortonworks Sandbox virtual machine for this activity. So first of all, we'll be needing Hadoop jar files for running the MapReduce code. Jar files you'll be getting from this link. And then you can select whichever version you want to download. When you download these, you can extract and then you can upload these jar files to Eclipse. Problem statement is that at a fictional country Utopia, there are 5 candidates. Now for these contestants, we need to calculate how many votes each contestant has got, and the voting takes place across different booths. So we'll be using MapReduce for this problem. So as you can see, we have uploaded these 3 jar files to my Eclipse, and using this we'll be running the MapReduce code side. Coming to the MapReduce program, we have 3 classes here: vote count mapper, vote count reducer, and vote count Java application. So the vote count mapper extends the Hadoop mapper class. Now here what happens is the mapper will take the input in the form of a key and value, and then it will throw out output. Now the output will be in the form of a word and 1. So for every word there will be a count of 1. Now 1 is iterable, and this is because the data needs to be serialized when it's sent across the network. Also when the input data comes in, the words are split according to spaces in between the words. But in our case, if you see the input, it is just 1 record per line. So there is no spaces, so it will not split based on this. Then coming to the reducer part, vote count reducer extends the Hadoop reducer class. Here what happens is count for every word is aggregated, and over the for loop the count gets iterated, and then we output the key with the iterable vote count, the total count for every word. And also in the vote count application for this code, this is the main class where we call the 2 other classes, mapper and the reducer, and then we also give the path names for the input format, input file, and the output file. That the set input and output format class is passed to the job functionality of Hadoop. Using the job functionality, we can set up, configure, and control the execution of the MapReduce jobs. These are our input files for the MapReduce jobs. Boot number 1 and boot number 2. We are going to export a runnable jar file to Cloudera. This can be done by clicking on the project, export jar file. Next, select the project, and then give the path of the place where you want to put the runnable jar file that will be pushing to Cloudera. Utopia vote count jar file that has formed on the desktop, and these 2 are my input files. So now these I will be pushing into the Cloudera VM. Jar file and the input files I will be copy pasting it into the Cloudera desktop. Then I can visit the file browser, and under user Cloudera, I have created a new directory called vote count input. This can be done by click on new directory, right clicking the name, and then inside this we can upload our files. Select the files, input files, and thus we have our input file ready. So now what we'll be doing is open the terminal, and we'll be running this particular command, yarn jar. Give the jar file name, enable jar file that we have exported. Then MapReduce is the package name, dot vote count application, which is the name of the main Java program which calls a mapper and the reducer. And then this is the path for the input, user Cloudera vote count input, which was our input file. And then this would be the path where the vote count output file will be generated with map and reduce output. When this is entered, simultaneously we can see it running in the job browser, where you can see that the MapReduce job is accepted and then running. So we need to wait till the time it is 100% completed. Let's move to the file browser and see the output. There is another folder that has now been generated, vote count output. If you go here, you can see that there's a success folder and part R. So when you click on part R, you will get to see the count of all the candidates. So here you can see that Jinjin is a clear win. So this way we are running the MapReduce, and we can see the number of count for each word. So this is the functionality of MapReduce that runs on Hadoop. Thank you.